Okay, hello, welcome back to our maths lesson. I am Mrs. Ray, your grade 9 maths teacher. In our last lesson, we looked at ratio. In today's lesson, we are going to look at proportion. Okay, when we are looking at proportion, we look at the alpha symbol to use for proportion. Alpha is the first letter of the Greek alphabet. Why we use Greek symbols a lot is because our modern maths is based on ancient Greek mathematics. So we will be looking at more of the Greek symbols in our formulas as we go throughout our maths lesson, and we'll explain to you what these symbols are. Now, we are going to look at proportion. Proportion is the comparison of two different quantities in the same ratio. Let's look at direct proportion. Okay, direct proportion is the comparison of two different quantities whereby the increase in one quantity also increases the other quantity. Now, let's say if y is directly proportional to x, we write that Sy is directly proportional to x. As an equation, we write that Sy is equal to Kx, where K is the constant in which x increases by. Now, let's look at an example where you work for the number of hours and the wage also increases as the number of hours increase. So we say hours of work is directly proportional to the wages that you earn. Let's say I work for 1 hour, I earn 12 kina. For 2 hours work, I earn 24 kina. For 3 hours work, I earn 36 kina. I can put this on a graph, okay, and on the y-axis, which is the vertical axis, that is the dependent variable, and that indicates the wages, 12 kina, 24 kina, and 36 kina. And on the x-axis, the independent variable, which is the time. For 1 hour, I earn 12 kina. For 2 hours, I earn 24 kina. For 3 hours of work, I earn 36 kina. And if I draw a graph, it will be a straight line graph. So from this graph, we can see that as the number of hours increase, the amount of wage also increases. So we write that as an equation, y is equal to kx, where k is the constant of increase, x is the independent variable, and y is the dependent variable. So we can see from this graph that when x increases, y also increases. Now, I am going to use an example. Let's say if y is directly proportional to x, what is k when y is equal to 6 and x is equal to 3? We want to find out the constant k. So we write our equation, y is equal to kx. Okay, that's the equation. We are going to substitute these values y and x into our equation to find the constant k. Okay, we have 6 is equal to k times 3. Since we are multiplying k by 3, we are going to divide both sides of the equation by 3. So 6 divided by 3 is equal to k times 3 on 3. 3 cancels out. 6 divided by 3 is 2. So 2 is equal to k. Our constant k is equal to 2. Now, let's find out what y is going to be if x is equal to 4, since we know the constant k. Okay, so we have when x is equal to 4, y is equal to kx. So y is equal to 2 times 4. Therefore, y is equal to 8. Now, our answer for y is equal to 8. So we know that when x increases, y also increases. This is the equation of direct proportion. Now, we are going to look at one example on real life situations. Okay, let's look at distance traveled and the time taken to travel a certain distance. And we are going to look at distance from, let's say, Leh to Mount Hagen. Let's assume that it is a straight road, so you are traveling at a constant speed. So we say distance is directly proportional to the time taken. So our distance is equal to k times t, where k is the constant, and in this k is the speed. So we assume that the speed is constant, and we know that the distance from Leh to Mount Hagen is 320 kilometers, and I am rushing. There is an urgent matter to attend to, so I want to get to Mount Hagen, let's say, in 4 hours. How fast am I going to travel from Leh to Mount Hagen so that I get there in 4 hours? So let's say 320 is equal to k, which is the speed, times 4, which is the time. Since we are multiplying by 4 to find k, we are going to divide on both sides of the equation to find k. So 320 divided by 4 is equal to k times 4 divided by 4. This cancels out. 320 divided by 4 is 80. 80 is equals to k. So, to get to Mount Hagen in 4 hours time, I have to travel at a speed of 80 kilometers per hour. That is my constant. Now, let's look at another example. This time, I want to travel a certain distance in 5 hours, but at a constant speed of 80 kilometers per hour. Okay, as we all know, distance is equals to the constant speed times time. And I want to travel a certain distance in 5 hours. And I am traveling at a constant speed of 80 kilometers per hour. So I have 80 multiplied by 5, that will give me 400. Therefore, the distance that I will travel in 5 hours at a constant speed of 80 kilometers will be 400 kilometers. Now, from these examples, we have seen that as the distance increases, or as the time increases, the distance also increases. So our independent variable is time and the dependent variable is distance. When time increases, the distance also increases at a constant speed. That brings us to the end of our lesson, and in our next segment, we are going to look at indirect or inverse proportion. Thank you.